Welcome to the Evolution 2.0 podcast, where we explore the intersection of art, technology, business, biology, and spirituality. Here you'll discover new trends in evolution that are changing the way we think about everything. This is your host, Perry Marshall, author of Evolution 2.0, 80/20 Sales and Marketing, and Guides to Ethernet, Google, and Facebook. I'm founder of the Evolution 2.0 Prize, a quest for the missing link between earth science, the information age, and life itself. Let's join the conversation now.
This is Perry Marshall. I am here with a very interesting special guest, Rich Jacobs, and he wrote a book called Finding Genius, Understanding Viruses, 30 Questions, 25 Geniuses, 100 Amazing Insights. And I've known Rich for a very long time because our relationship started out as him being a client. And then he went down the rabbit hole of science and started I don't even know if it was science at first, but he started a podcast where he was interviewing early on. It was a lot of cryptocurrency guys. And then one thing led to another, and he was going down science rabbit holes, I think in part inspired by Evolution 2.0. And he started getting into this groove. Now, I know a few rare people who read a book every day. Well, Rich almost interviews a podcast person every day. Not too many people who do that. And he's got this podcast called Finding Genius, and he's interviewed a lot of geniuses. Rich, how many, roughly?
In a couple months, it'll be 3,000.
Okay. So this is a lot of interviews. And when you're going all across interdisciplinary boundaries and jumping from subject to subject, everything from cancer to genetics to viruses to cryptocurrency to big tech or whatever else, you start to notice some things. And so today I want to talk to Rich about his virus book, but also kind of put it in a wrapper about what do you learn when you talk to smart people and what kind of smart categories of smart people are there and which ones do you think we need the most of more. So, Rich, here we are. Mm-hmm. Why don't you give your version of what I just told everybody? I know mine was maybe not completely accurate and very compressed. So how did this come about?
Yeah, no problem. So in 2016, I was caught up in the Trump and Hillary election, and I was angry every day about it, as I'm sure a lot of people were. And I had started getting emails from Peter Diamandis, the founder of the X Prize. He's like a polymath into all kinds of different things. And I would read his emails, and they'd talk about 3D printing and AI and organ transplants and stuff like that. And I felt happy, and it was futuristic and cool. And then I would look at the news, and I'd get pissed off. So I finally said to myself, enough. I'm not looking at the news anymore. What's the point? It just makes me upset all the time. I'm going to focus on this interesting stuff that makes me happy. So I did that. And at that time as well, I had learned about Bitcoin a few years ago. And I was talking to my wife, and I'm always pestering my wife with questions. It's just how I am. And she says, go learn something. Stop asking me questions. So I decided to start a podcast because I could ask questions of these people in these articles I was reading. And so I started, and I did a lot of interviews on cryptocurrency. I did some AI and 3D printing and quantum computing and all that stuff. And I did that for a while, and I just loved it. It was amazing. At first, it was like trying to drink from a fire hose of knowledge. It was overwhelming like crazy. But I kept doing it and getting better at it and enjoying it. And so it went on. I got up to be hundreds of interviews, and I ended up putting on a conference about cryptocurrency because I interviewed at one point, it was like 350 different organizations and companies and individuals in that space. So I pictured myself as floating above the space, like a 10,000 foot view, and looking down at all the players. Where are they going? What are they doing? Like ants in an ant farm, So I just got more and more into it. And then in end of 2017, I was coming home late at night, and I got into a car accident. Someone hit me and ran me off the road. And I went to the doctor, the emergency room. They found I had, a concussion. I had nodules on my thyroid, which I didn't know what that meant. It turned out to be thyroid cancer. So all of a sudden, now my focus shifted not just from futuristic technology, but more to medicine, health, bioscience. And from there, it's not 100% that, but it's 80-90% of that focus. And, there's a lot more to say about it, but that's a brief intro of how I got into it and how it's come to this point.
Okay, so along the way, you have picked up some really interesting patterns about how people think. So you did crypto, and congratulations on getting into crypto before it was super hot and all of that. So that's great. But then you started going into other disciplines. Then you started getting into scientists. And in your book, especially at the beginning, I think the book is worth getting and reading, even if you just read the first chapter or two, because you explain what you've discovered about people who ask questions and search for knowledge for a living. Could you talk about that in whatever way you find the most interesting?
Yeah, sure. This became the intro to the podcast, but I realized in any profession, 95% of the people they're good enough to be licensed in it and to be a CPA, a doctor, whatever it is, a researcher. And, they can help you, which is fine. And then this one added to 100%, but close, just for ease of numbers. About 5% are really good. They're top in their field. And if you have a significant problem, you want to go to them. Or if you really want, a super smart person. And then there is probably 0.1% that I literally think they're just geniuses. And I would notice every 10, 20, 30 calls, within 5 minutes of talking to somebody, I was like, whoa, this person's really, really levels and levels above and beyond the other people I've spoken to about this particular topic. And those became my favorite interviews. They were just crazy. I remember thinking I don't know, I just remember being amazed by some of these people. So I saw that, and I saw that when I would go into a new field, the first few interviews, I don't know what I'm doing. I don't know the terminology. I ask okay questions. And once I get to 20 or 30 people in a given field, now I can ask much better questions. And now people are starting to say, what's your background? How do you know this stuff?
Yeah.
And in a few fields, I kept going to 100 people. And then you can ask some killer questions. And that's when I started hearing, I don't know. That's a good question. I don't know. And some people would say, do you want to work with us? So, it was fun. So that's one thing I noticed about the structure of any field is that, again, it's going to be divided up into those people. One useful thing I found from that is, let's say, God forbid, you have a problem, you have cancer, you have whatever's going on with you. Do you have a 95% problem, a 5%, or a 0.1% problem? And you need to know that, because if you have a 0.1% problem, by definition, you've got to talk to a lot of people in the field, or you're not going to get the help you need. You need to sift and sort until you find the rare geniuses in that field. Otherwise, unfortunately, you're in a bad spot.
So in other words, if I got a cavity in my tooth and it's ordinary cavity, that's a 95% problem. 95% of dentists can solve that problem just fine. It's routine, right?
Yes.
But if I got some hideous thing going on with my, I don't know, $80,000 of cosmetic surgery, I was a big car accident or something like that. You don't go to any ordinary cosmetic surgeon, you go to one of the top 5%. Or if it's super life and death and ridiculously complicated, you go to the 0.1% guy. Is that what you're saying?
Yeah, I'll take cancer because you're pretty familiar with it. And unfortunately, a lot of people are. I had thyroid cancer, it's weird to say, but it's one of the best ones you can get. It's got one of the highest cure rates. So it was not a big deal. If you have triple negative breast cancer, or you have, a brain tumor or aggressive pancreatic cancer, you've got to get top help. Otherwise, the odds are not good for standard of care. So again, depending on the seriousness of your condition and whatever's going on with you, you need to know that. And if you do, you'll be like, okay, I need to talk to a lot of people until I find that gem. And then that's who I go with.
So I get this friend, Emerson Sparts. He's a professional learner. He made a bunch of money in crypto. He's early 30s. And now he used to be a CEO of a company. And now he just does whatever he wants. And what he wants to do is learn. So he does whatever he needs to go, like wherever he needs to go to learn. And, every few weeks he picks some new topic and he goes down the rabbit hole. And what he said to me, it was very similar in ways to what you just said. He said, when I go into field, I spend like 20 hours figuring out what's the terminology, who are the experts, what's the lay of the land, how does this work? And he sort of gets a sense of things. And then he says, and then somewhere along the way, I'll run into what I call an interdisciplinary explainer. And this person gets me farther in 1 hour than the last 20 people got me in 20 hours. And he said, this person is usually interested in a bunch of things, and they're adept at explaining a bunch of things, and they understand multiple fields, and they can explain all of them in plain English. And he said, those are the people that you're looking for. And I guess what I'm hearing, it's not exactly the same, but you're saying something kind of similar.
There's more to it, so I'll tell you now. So when you first start interviewing people, again, you don't know a lot, and you might pass over a genius because you just don't know what to ask them. And as I get better in a given field, I could ask better and better questions. And then I would return sometimes to the original people I talked to. And it's weird. It's like interviewing a completely different person. Like, Perry, if I interviewed you on evolution, I would get one Perry. And if I interviewed you on marketing, I would get great answers still, but I would get a completely different Perry. And that's what I noticed about some of these top people, which is cool. It's like an oracle. Depending on what you ask it, you get something from it. Another phenomenon I noticed is I would ask questions and people would say, I don't know. And then I would ask 6, 7 people the same question. And then all of a sudden I get someone and they would say, oh yeah, I know about that. Here's an example of it. And I would think, why don't these other people know it? They're experts in their field. And the further I get into a field, or the further anyone gets, the more you'll see that. You see, like, people are busy. They just don't have enough time to read all the papers in a given field and talk to everyone and associate with them. And they may be competitors, et cetera. So people are siloed not only within their field, but within their knowledge and within their communication. And that's not good. And if you want to solve the big, incredibly difficult problems, at the very least, you've got to get together a consortium of people in the field and really go interdisciplinary like you're talking about. Otherwise, you're just not going to solve it. I see a lot of these researchers, I feel bad. I mean, they're going to go down dead ends for decades. I just see it. They're focused on this one enzyme. And I ask them ancillary questions about it. And they're like, oh, that's not my area. That's not my field. Science in general and knowledge in general really does need to be more interdisciplinary and more, it needs to utilize the great minds that are working on a given problem to really solve it.
It's kind of this unfortunate fact of life, because I don't know how many entrepreneurs that I've told, well, the way that you're going to be successful is by narrowing your focus. You need to be the best in the world at this one thing, and then you'll have customers. Right now, you're too much of a generalist, and that's true, especially when you're getting started. But what you're pointing out is that people do that. They get established in a niche, and then they just stay there, and they get narrower and narrower. In fact, Rich, could I tell you another little story that I maybe you can jazz improvise off of?
Sure.
So
sure.
We did this Cancer and Evolution Symposium in October of 2020. And we had all these speakers, and I really thought it was a great conference. And I got a call from this guy that I sort of knew. And he goes, Perry, he was in the pharmaceutical industry for 30 years. And he goes, Perry, that was the best conference I have ever attended in my entire career. And I go, cool. Explain. And he goes, there's two kinds of people in the world. There are splitters and clumpers. And I go, okay, what does that mean? And he says, splitters are the guys that study that one enzyme, and they just go deeper, deeper, deeper. Like, there's really almost like no limit to what you can learn about some enzyme. Like, it just goes for miles. And so They just subdivide, and they learn more and more about less and less. And they don't look up in their cubicle. They just keep their head down and they just go. And he said, those are splitters because they subdivide knowledge smaller. He goes, then there's clumpers. Clumpers are the guys or gals who stand up and they look around, they go, hey, has anybody noticed that the guy working in cubicle 14, it's almost exactly the same problem as cubicle 37, even though they're in different fields? And hey, does anybody know the answer to this? And does anybody know the answer to that? And most people are like, well, I think those people over there do. And then he goes and talks to those people over there, and like he assimilates different fields of knowledge. And Vince said to me, he goes, almost all of your speakers were clumpers or assimilators, not splitters. And that's why it was such a great conference. Now, I think this is almost exactly what you're talking about, which is once you've got a niche and you can make a living and you've figured out a part of the world, you should start standing up and walking around and looking at how does this relate to other fields, maybe even fields very far from what I'm currently doing, because there's an unexpected insight that's going to come. Is that about right?
Yeah, I mean, you've taught this before. You take, principles from biology and apply them to business. You take, like drive-throughs. I guess banks were the first to have it, and then restaurants took it up, the drive-through.
Yeah.
So yeah, definitely. I'm not complaining about these people. I understand why they have to do what they do. They've got to run their lab. It's a business, et cetera. They've got to get grants and all that. But they can look outside their field more to get help. And they really need to. Like, I remember I interviewed this lady about esophageal cancer, the esophagus. And I said, what about the epiglottis? The flap that covers the entrance to it. She goes, oh, well, we don't work on that. Well, it's right next to it. Maybe that gets affected. What about the sphincter that leads to the stomach, the other end of it? Oh, no, we don't. There's people that specialize in that sphincter. Okay, well, I didn't tell her, but I said in my mind, I'm sorry to tell you, you're going to be, you're not really going to go very far being that narrow. So yeah, you have to go outside of your comfort zone in order to get the knowledge. And when you're ready, I can tell you about the virus book and how that worked.
I am ready because this is probably the perfect way to segue into, okay, so Rich decides to like assimilate a bunch of information about viruses. So how did that start?
I've been really fascinated about viruses, and, obviously COVID came, and very quickly I got so sick of talking about COVID. I just never wanted to talk about it ever again. But viruses are super interesting. I had interviewed probably 100 virologists by that time, and I was going real deep into it and getting really interested. And then I thought to myself, there's all these questions I'm asking them they don't know the answer to. What if I take all the hardest questions and then I re-interview the ones that I think are best and ask them only those questions? Let's see what I could do. And I did, and it was like the Olympics of interviewing. Like I remember I interviewed Eugene Koonin, who's like a really big name in viruses, and he has a funny way of talking, but I just love getting people. And at one point he goes, I don't even think there's an answer to this question. This is crazy,
Yeah.
I got people laughing when I would ask questions, and I got most of the answers. I said, go ahead, speculate. It's okay. I know it's just speculation. And they would, but people loved it. They were literally tickled by some of the questions because they would laugh. And I was like, all right, I'm really onto something now. And doing the interviews, again, it felt like the Olympics of interviewing. I'm like, how can I keep taking this to the next level? And that was the next level so far.
So what were some of the questions that made people laugh out loud?
The big one really that overlays the entire book is, are viruses alive? Why or why not? That really is the underpinning for the entire book, because if you're, let's say, a neo-Darwinist and you just think everything's random mutation and natural selection, those interviews are actually pretty boring. They were. They had no answer. There was no answer to most of the questions, The people that were willing to entertain that viruses are alive, at least in some sense, then the conversation could go somewhere. So that was the real initial hurdle to get over. And I would ask questions like this, like, why do some people get infected with viruses that are quiet and go latent for decades, and then all of a sudden they flare up? What's happening? Is the virus reading the condition of the host and saying, okay, now's the time for us to make them sick again or proliferate, stuff like that. I asked too, if you were able to create a cell and sucked out the contents, or if you made like essentially like a lipid bilayer empty cell and it had the right receptors on it, would a virus still dock with it and infect it and inject its genetic material and find no one home and be trapped? I asked a question like that. There was about 30 questions I asked, and another one too. So if I get infected with a virus and I label myself number one, and then let's say I cough on somebody and they get sick, they're number two, and I passage it just naturally, what happens at person number 100? Is the virus worse? Is it not as bad for them? Are viruses headed towards some kind of coexistence with their hosts, or are they going in the other direction and getting more and more virulent and killing them faster? So that's some of the questions I was asking.
Well, they're great questions. And I like the format where you present a question, you explain a little bit, and then you give, well, I got this answer from this guy, I got this answer from this lady, and go to page 225 if you want to read their bio. And so you kind of collate these answers. So where did this take you in Rich Jacobs' philosophy of viruses?
Well, it took me to the point where, again, I'm 99% sure viruses are alive. And not only that, this is going to get a bit technical, but when you get infected by a given virus, you're not infected by just one virus with one particular strand of RNA or DNA. You're infected by billions of viruses that have variations in their DNA or RNA. So you're infected by a population. And I think that the viruses actually use this differing population to be able to infect better and to be able to, accomplish their job, whatever it may be. I think it's also a memory. So when a virus infects someone and they leave that person and go on to infect someone else, the viruses that were able to enter the cells and effectively commandeer them and make more of them are the ones that are going to survive and get passed on. But it's heterogeneous. They're not going to be all one particular flavor of virus. So I think that viruses actually are alive and they're a group organism and that they have a memory. And the memory, again, is these different viruses that have different sequences that are slightly different. And they infect, again, as a population, and they adapt to each creature that they infect and then move on and move on and move on. So I think that's one of the really surprising implications of it.
So what does it mean for a virus to be alive? And go anywhere you want to go with that. Why is it a question? And what does the question mean?
Well, a lot of people think that because a virus can't reproduce on its own, that it's not alive. That's one big, stumbling block people have. But okay, so these are some of the questions that come up around it. Viruses appear to have what's called tropisms. So if I get the flu, I get it usually by inhaling, let's say, respiratory droplets, coughs, sneezes, etc., from other people. I don't get it from sex. And when I do get it, guess what tissues it affects? My lungs and my respiratory system. And then I'm encouraged to spread it. It makes me cough and sneeze and all that to spread. How could it know that? And why would HPV that's spread by sex or syphilis or other stuff only spread that way and affect those tissues and then cause the infected creature to, let's say, be more promiscuous or have more sex? This doesn't go for all cases, but it goes for a suspicious large number of them. So viruses appear to be attracted to certain tissues. They know how to enter those tissues. They know how to cause the host to, again, cough them out or in rabies, bite someone else and spread. How could they know this? The organism is not them. The only way I believe they could have known this is they've adapted over time, multiple times, I don't know for how long, and they're geared towards that host, they're geared towards those tissues, and they know what to do. You see this in parasites as well. There's parasites that cause their hosts to literally act in certain ways to cause them to be consumed by another animal so they can spread to that new animal. How could it know this?
Well, so Rich, there's like a standard answer, which I think is really, really lazy. which is, well, natural selection just selected the ones that can do it, so they can do it, which is a complete non-explanation. It evades everything. It's like eating a Ziploc bag and thinking you got a ham sandwich, right? And so this is like the standard neo-Darwinian answer to everything is natural selection, but it's an outcome, not an explanation. And so usually, like you're talking about this question of agency of, well, how did they think of that? Or how did this get engineered? Well, evolution 2.0, we just categorically reject this non-explanation. Like, no, you actually have to come up with something. It sounds like where your mind has gone is there is something desirous, or there's an attraction factor of the virus conforming to its environments for the purpose of its own goals. And so you're assigning agency in some degree to the virus itself. Is that about right?
Yeah, I'll give you a few more examples. I'm sitting in my car doing an interview, and I do a lot of them in my car because I move around a lot. And I'm looking at some trees, and I'm thinking, okay, well, everyone knows that they're alive, but what about the seeds of tree? Let's say it's a pine tree. What about the pine cone? If I look at it, it's not moving, it's not doing anything, and it can sit that way for months or years. And if I zoom in to the microscopic level and I look at its tissues, are they moving? Maybe the atoms are jiggling, but it's probably not moving at all. But yet, would you say the pine cone is alive? Well, in that state, it's in stasis, it kind of is, it kind of isn't. But as soon as it finds soil and water, now all of a sudden it springs to life. So what was it when it was in that state? So then I think of viruses, we only see them when they infect some creature and they're active and they're commandeering the cells and everything. We don't see them in their virion state. Supposedly they're inactive and just floating around. So I thought, okay, maybe that's what viruses are. They're just, in their virion state, in their inactive state, they're like seeds. And then when they're active, But I think that further supports that they're alive. So that's one realization. I did an interview, I forget his name, I'll have to find it, but he's studying what's called the ARC gene in human cells. So human cells, he shows me, are able to literally produce these extracellular vesicles, these like lipid-bound carriers that can carry DNA and RNA and all that. But the ARC gene in people actually can create virions. It can create capsid that looks exactly like other kinds of viruses, package genetic material into it, and send it out in the body to other cells. So now we have human cells literally creating at least certain kinds of viruses. So where does that take us? So these are some of the new thoughts that came up.
I think it's really interesting to ponder like this, well, what is alive? Like even defining what alive means is kind of elusive because like you go, well, able to reproduce. Well, my wife's mom is 90 and she's not able to reproduce, but she's definitely alive. Like you can have all these arbitrary definitions. It's almost like, whatever a virion is when it's just floating around or sitting on your kitchen table, it springs into action as soon as it touches the right thing.
Here's another thing I thought of. So, an average virus is 50 to 100 nanometers in length or width, okay? Compared to a human cell, it's minuscule. So imagine, and people say, oh, it's just numbers. But, again, imagine trillions of viruses supposedly inside of you. Look how big you are compared to the viruses. How do they find their targets? How do they find the right cell, the right receptor? How do they line up to enter the cell? And how have they done this reliably quadrillions of times throughout all of history? They're so tiny and they're just floating along and they have no motility or anything. How do they find their targets? And how have there been literally quintillions of infective events throughout all time? How's that possible?
Well, I think a lot of people like to keep their head down and not really ask questions like this. Like, well, I don't know, but I'm an expert on this protein.
Yeah, and I want to know, I'm actually wondering, well, people want to know, where do viruses come from? They may actually have their origin, and I think they do, inside of various creatures. I think at least some viruses, and I've seen this again by interviewing some people, our body produces certain ones. So viruses are a tool of cells, but they also use cells as tools. They're multiple things at once. They're not only one thing. Like I've talked to researchers that say that certain bacteria will be attacked by a phage, which is a bacterial virus. They'll take the genetic material of the virus and they'll reuse it. So I've heard examples of bacteria creating their own spike protein and using that to impale other bacteria, blow them open and take their contents and kill them. So again, viruses are used as tools of cells, but they also use cells as tools for their own ends. So it's a very strange arrangement.
So when you say they use cells as tools, tell me more about that.
Well, there's a scientist, Patrick Fortier. I'll probably mispronounce it. He's French. He came up with a concept called the virocell. So when a virion enters into a cell, now you have this new combined organism, the cell and the virus. He calls it a virocell. And again, there's not just one thing that viruses do. So yes, they will instruct the cell to make more of them at certain points and continue to infect other cells. But sometimes they don't do that. They go latent. They hang out inside a cell and don't damage it. Why? Who's making that decision? What are the conditions that cause that? Let's say I have 1 billion cells that have been infected by some virus, herpes 10 years ago. How does the signal get around to the different jail cells that now's the time for the herpes to flare up? There's viruses sitting inside all my cells. They're hanging out. They're not active. Something happens. Is there a quorum sensing where they communicate with each other? And now they say, all right, the conditions are right, whatever they may be. Go ahead, let's infect. What orchestrates that? Is there a hive mind? I mean, I know it's getting crazy, but I picture a virus as a person sitting at the control panel, let's say like a spaceship. They get in there, now they're at the control panel and they can decide various things to do. And they don't seem to do just one thing. And they do seem to do things based on cues and at certain times. So that tells me they're not just inert things. There's no way. And some viruses will insert themselves into, a bacteria's genetic material. There's viruses that insert themselves into our genetic material. I don't know if listeners know, but about 8 to 10% of all of our genetic material supposedly are ancient viruses that became part of our DNA. So about 8 to 10% of us is viral DNA that we use. Like our placentas that placental mammals form, they use a compound called syncytin, if I pronounce that right. And again, that's a viral protein. It's not normally found in regular animals to produce that. So the story just gets crazier and crazier, and the rabbit hole just gets deeper and branches off left and right. I don't know where it goes yet.
It's interesting to think about. It's easy to object. Oh, viruses can't be alive. Like it's just a strand of DNA and it's a protein. And you go, well, a cell is obviously alive. But see, we don't really what makes the cell alive. So if you don't know what makes the cell alive, how do you know the virus doesn't have some of that too? We don't even know what it is. It's a central mystery in biology, like what makes life alive. Nobody.
Yeah, if you look at a cell, where is the life in the cell? If you start torturing it and ripping out its mitochondria, is it alive or dead? If you take its ribosomes, where is the life in the cell? I don't know if you can find it. I think life may be an aggregation of quote unquote enough elements that make something alive, but no one knows what that is.
It's a very elusive question. It's a very interesting question. And how comfortable are scientists talking about this?
Oh, they're not. I understand they have to be careful what they say. They don't want to endanger their grants and all that stuff. And they're also afraid to speculate because people will say they're idiots. They have to be really careful. And if you're kind to them and you talk to them and you're friendly, they'll speculate. But if they sense at all it's going to endanger them, they can't and they won't. Again, they've been trained not to, unfortunately, which is weird.
Well, I just think this is really fascinating. I really enjoyed your book. In fact, I got a couple chapters in. I just went and wrote an Amazon review. I'm like, this is a great book. It's called Finding Genius, Understanding Viruses, 30 Questions, 25 Geniuses, 100 Amazing Insights. And I really get the idea you had a huge amount of fun talking to all these people.
like I said, it was thrilling, literally. I know it sounds nerdy, but
Well, it is.
It felt like the Olympics of interviewing, but it literally was thrilling to do it. It was fun.
And so just to wrap up here, what are some virus rabbit holes that you started to go down since after you wrote the book? Give me a sense of where it seems to be going.
I'm wondering if extracellular vesicles or exosomes, so cells produce these thousands a day, and they send them out and they go to other cells and they enter into other cells and change their genetics and et cetera. And then they also are intaking, there's inbound thousands of different ones as well. They have all the hallmarks of viruses to me. They're membrane bound, virus is very, is a protein bound, or, it has its outer coating. Okay. They contain genetic material. Viruses do too. They can be produced by cells. So can virions. They can enter into other cells readily through receptors. So can viruses. They look very suspiciously to me like viruses, just a slightly different flavor of them. And when I look at like bacterial plasmids, they seem to have all the hallmarks too. So I don't know where that's going, but again, extracellular vesicles seem to be suspiciously very similar to viruses. And now that I know cells can produce some of their own virions and viruses, again, I have no clue where this is going, but it's going in a very strange direction. It's weird.
So, like maybe viruses originate from cells that are communicating with these exosomes. Is that a possible guess?
Yeah, viruses may be offensive weapons from a given creature so that it can breed and proliferate and dominate others in its ecosystem, its local area. Viruses may be a weapon that we have no clue even that we are creating to attack other people. They're also used in defense of self as well, but yeah, they may be that.
Wow. Well, this is just really fascinating. Tell everybody, how do they listen to the Finding Genius podcast, and how do they get more of Rich Jacobs?
Oh, thanks, Barry. We have a website, so we have findinggeniuspodcast.com, or we're on, iTunes and Apple and YouTube and everywhere else you could think in the world. We try to put it on every channel possible. So that's the best way to find out more about the podcast. And then, the virus books on Amazon, Audible, and Kindle. You can go get it there. I'm also working now on a cancer book, which my goal is end of September, it'll come out. That's, for some reason, it's been a much bigger project than even the virus stuff. So same format, interviewing people, having the questions and answers. So that's coming. And over time, I hope to make a series of books on different topics. And I guess it'd be chicken soup for the scientist's soul in a way. All these variations. So yeah, that's the best way for them to find stuff out.
That's fantastic. Well, Rich, congratulations on going down the rabbit hole. I think one of the perks of being an entrepreneur and having earned a certain amount of freedom in your life is you got to go do stuff like that. So here you are, and you're enjoying it.
Yeah. And by the way, Perry, your Evolution 2.0 book really was like the initial tipping point that inspired all this. So thank you for that. And I encourage listeners, obviously, to listen to everything Perry's got, because you've got a lot of great resources, and thank you for inspiring me.
Well, you're welcome. And thanks for I didn't know that anybody was going to go do this. And I really encourage people to go on their rabbit trails and follow where these fascinations lead, because you don't know. And there's no way anybody could be certain that you won't make a big contribution to virus research. Like, if I had a police lineup of virologists and Rich Jacobs was in the police lineup, and you said, who do you think is going to make the next breakthrough? I might put a bigger vote on Rich than if I didn't know who any of the other ones are. I'd probably vote for Rich a lot sooner than I'd vote for somebody who's specializing in some little thing, because that's what most people are doing. So I'm not trying to put down any virologists, but what I am saying is that outsiders have a unique ability to see patterns that seem like they should be obvious. Rich, don't you get people saying well, how did you even think of that? That's like a really brilliant question. Don't you have a couple stories like that?
That's what drove me nuts. Is I remember I spoke to a heart researcher. He's been doing it for 35 years. He's also a surgeon. And within 10 minutes, I'm asking him questions, and he goes, I don't know. That's a good idea. And how can I do that? I'm not a genius, but how could I? Almost every interview now, I can, it's like a game. I want to get them to say at least once, that's a good question. I don't know. How can I do that? When I'm not in a given field, I'm not in cardiology, whatever it is. And again, I'm talking to people with decades in the industry, and I'm coming up with stuff that they don't know the answer to. That tells me that they need to be talking to their colleagues more, that they need to be thinking outside the box, that they need to be checking into ancillary fields that could help them. Like, for instance, if you're going to study viruses, you need to study bacteria too. You can't just ignore them. And you need to study extracellular vesicles. And you need to study a whole bunch of stuff. I know you can't study everything in the world, but you have to at least be open-minded and talk to people in ancillary fields to help you, because otherwise you're just lowering your chances of any great discovery. If you only look narrow, your chances are your discovery is going to be narrow.
Well, I couldn't agree more. Rich, congratulations, and really nice job in the book. Like I said, it was worth buying it just to read the first couple chapters, and it's all good. So,
yeah, thank you, Barry.
Until next time, this is the Evolution 2.0 podcast, bridging science, technology, business, and the big questions. To ensure you never miss an episode,